All right, let's dive right into this explainer. We're going to do something absolutely incredible today. We are taking a conceptual starship directly into the abyss of a black hole. Now, we've all heard the stories, right? That black holes are these ultimate cosmic traps, places where gravity is so intense that literally nothing escapes. But today, we're throwing out what you learned in high school. We're relying on the cutting-edge theories of quantum gravity to figure out what actually lies at the very bottom of that dark pit. Buckle up, because reality is about to get extremely weird.
Welcome to our channel, where we explore the darkest corners of the cosmos, the mysteries, the threats, the unknown. This is space like you've never seen it before.
So, imagine you're boarding our ship and we're flying straight towards Sagittarius A star. That's the enormous, supermassive black hole sitting right at the center of our very own Milky Way galaxy. We want to find out exactly what happens when you cross that ultimate edge, the point of no return. Do you just disappear? Are you crushed into infinite nothingness? Or is there a completely different, much wilder truth waiting for us on the other side?
Section 1. Approaching the black hole.
Before we cross that infamous point of no return, let's just hover here for a second and look at what we actually see from the outside of this absolute cosmic beast. We chose Sagittarius A star for our journey because, well, astronomers have actually taken its picture. And to do that, they didn't just use one normal telescope. They had to use a massive network of radio telescopes working together to create an antenna, essentially as big as the Earth itself. And what they captured was this very distinct glowing ring of light surrounding a pitch-black center. Now, here's where it gets kind of mind-blowing. That glowing ring isn't physically a flat circle like some cosmic neon sign. It's actually an optical illusion. The black hole's gravity is so impossibly strong that it literally bends the paths of light rays around itself. It grabs light from the matter spiraling all around it and warps it so intensely that it creates this glowing sphere. So no matter what angle you look at it from in space, you're always going to see that brilliant ring because the light is being perfectly wrapped right around the darkness. As we get closer to the edge, we start experiencing this bizarre phenomenon that Einstein predicted. It's called time dilation. Basically, gravity slows time. If we just hovered near the edge and watched a clock fall in, it would appear to slow down and eventually just stop completely. But for us inside the ship, time feels totally normal. Here's the crazy part though. If we looked back and received messages from Earth, let's say they sent one every single day, they would start arriving at warp speed, every hour, then every minute, then every second. We would literally be sitting there watching the distant future of the entire universe unfold right before our eyes.
Section 2. Falling into the abyss.
Okay, it's time to turn off our rockets, ignore those outdated physics textbooks that say we're definitely going to die, and plunge straight into the dark. As we cross the horizon, honestly, it feels a whole lot like the Italian poet Dante entering the gates of hell in the Divine Comedy. We are leaving the absolute safety of the outside universe behind and stepping into the complete unknown without a tether. But hey, as scientific explorers, we're going to push forward anyway. If you crack open a textbook, it'll tell you a black hole is just a static sphere with a set volume. But once you're actually inside, according to general relativity, space is brutally distorted. It isn't just a simple sphere at all. It's an immense, ever-changing tube that is literally millions of light years long. And remarkably, this tube is simultaneously growing longer over time, while violently shrinking and closing in all around us.
Section 3. The quantum bounce.
As space shrinks around us tighter and tighter, we eventually hit a hard limit where classical physics just totally stops working. Just like Dante lost his guide Virgil deep in the circles of hell, we lose Albert Einstein's theory of general relativity right here. At the absolute bottom of this crunch, the curvature of space is just too extreme. And Einstein actually knew this. Back in 1916, he wrote that his own equations couldn't explain this extreme crunch and would eventually need to be corrected by quantum phenomena. We are completely off the classical map now. To survive this, we have to turn to a tentative, modern theory called loop quantum gravity. The crucial takeaway here is that space isn't infinitely continuous. You can't just keep dividing it in half forever and ever. Much like how light is made of individual little photons, space itself is granular. It's made of tiny, indivisible, finite grains. It actually has a quantum limit, which means the black hole physically cannot shrink forever into a point of infinite density, or what's known as a singularity. So because space literally can't shrink into nothingness, what happens? Think about a falling ball. It eventually hits the floor and bounces back up, right? Well, the shrinking black hole hits that granular quantum limit of space and undergoes a massive quantum leap. It entirely reverses its geometry. The star collapses, the black hole forms and stretches, it hits that quantum limit, jumps, and a white hole opens. A white hole is a cosmic horizon where things can only exit, nothing can enter. Section 4. White holes and dark matter. Let's move to the next phase and see how this builds into an entirely new cosmic phenomenon, one that might actually solve one of our biggest astronomical mysteries. Now, you might be wondering, if this happens, why haven't we seen these white holes erupting everywhere? Well, it all comes back to that extreme time distortion we talked about earlier. To an observer waiting safely outside in the universe, this bounce process takes billions upon billions of years, literally longer than the current lifespan of the universe itself. But for us on the inside, in free fall through the geometry, that massive jump from black hole to white hole feels like mere minutes, maybe even seconds.
Actually, a massive black hole won't undergo this quantum jump immediately. As the brilliant Stephen Hawking proved, black holes slowly evaporate over time by emitting energy. They shrink and shrink and shrink for billions of years until their horizon becomes microscopically small. It's only when they get incredibly tiny that the probability of this quantum jump occurring actually becomes highly likely.
And when that white hole finally pops out at the very end of this incredibly long evaporation process, it is microscopically tiny. We're talking about something with a mass of roughly 1 Planck mass. To put that into perspective for you, that is a fraction of a microgram. It is the exact same weight as a single strand of your hair. Which leaves us with a truly fascinating, completely paradigm-shifting speculation. Look at the properties of these tiny, ancient white holes. They would only interact through gravitational pull. They'd be completely invisible to light. And, if the early universe was chaotic enough, billions of these microscopic white holes could just be floating around galaxies right now. Does that sound familiar at all? Astronomers map these massive, invisible halos pulling on galaxies today, and they call it dark matter. Could dark matter actually just be a swarm of tiny, ancient white holes? Honestly, it's a thrilling possibility. Section 5. The power of perspective. Well, we've survived our trip through the quantum bounce, and now it's time to zoom out and look at the bigger picture of what all of this really means for us as thinkers. Doing theoretical physics requires a concept called mind traveling, and it's the exact same imagination used by ancient thinkers. Anaximander mentally stepped off the Earth to map it floating in space. Hipparchus measured the moon by imagining the Earth's shadow from deep space. Kepler literally wrote a whole story about viewing the Earth from the surface of the moon, just to prove his theories. They had to mentally leave their homeworld to finally understand our actual place in the solar system. As we wrap up this explainer, I want you to remember that science isn't just a collection of cold calculations and static textbooks. It's this beautiful, poetic act of stepping completely out of your own world, abandoning your usual point of view, just to see the universe as it truly is. So, I'll leave you with this. If understanding reality requires leaving your established perspective behind, what perspective are you willing to change today?
If this video made you think, hit like, share it, and subscribe to this channel. Because the next mystery is even deeper. Until then,